So we have already seen how the position of an object can be found by finding the integral of the velocity function. The change in position is the displacement. So if I go 2 steps forward and then 1 step back, the total distance I have traveled in this scenario is 3 steps. However, the displacement in this scenario is 1 step. Because what is the displacement? Yeah. Displacement is, in layman's terms, right, where you are in relation to where you start. So let's consider this example. Example 1, suppose the function v of t is equal to 5 sine of t cosine of t on the interval for t between 0 and 3 pi over 2. It's the velocity in meters per second of a particle moving along the x-axis. The graph is shown to the right, and the initial position of the particle is 4 when t is equal to 0. So the integral from 0 to 3 pi over 2 of 5 sine of t cosine of bt is a specific example of an integral from t1 to t2 of v of t dt. What are the units for my velocity function? They tell us they are meters per second. And what does the dt represent? It's the change in time. And the units for time, seconds. So what do T1 and T2 represent in the integral? It's the initial time and the final time. Initial and final time. So part D says, find the acceleration at t is equal to pi using the calculator and give units. So it has been my experience that students, for the most part, do not make full use of the calculator like they could. So let me try and help you with that. All right. The AP exam is roughly 60% non-calculator, 40% calculator, maybe a little higher on the non-calculator, okay? Of the free response questions, 2 are calculator, 4 are non-calculator. To be honest, I think that the non-calculator ones are easier because they have to give you something that will work out. On the calculator questions, they can give you whatever they want because it's calculated. But say all that to say this, especially on the FRQs, the very first thing that you do is put the equation into your calculator. Triple check to make sure that it is right, but put the equation in your calculator and then you will use it taking advantage of the shortcuts of the calculator. Okay, so in this case, to be honest, it doesn't matter too much because this is a fairly simple equation, but on the AP exam, that might not be the case. Okay, so get your calculators and go ahead and put 5 sine of t cosine of t in there. Let me stop the share for a second.
Attendance, please.
Okay, so you should have this. All right, so they asked for the acceleration And in order to get the acceleration from the velocity, I need to take the derivative. So my equation is in my calculator. I have 5 sine of x cosine of x. So I'm going to go to my good friend from the first semester on the calculator, math 8. Math 8 and deriv. Okay, so this is with respect to x. So look at this for a second. This is the shortcut, okay? And like I said, it's not that much of a shortcut in this case because the equation is not complicated, but you only put the equation into your calculator once. Then you use the shortcut. Okay, so I'm going to go to alpha F4, alpha trace F4, and then Y1, enter. So what that does is the equation that you stored in Y1 is now stored in the calculator's RAM, and it automatically puts it in there for you.
Wait, hold on. You need to wait. Not cool. You said alpha what?
F4, alpha trace, enter,
Trace, and then it's
enter, Y1,
Oh, okay.
because that's where you put the equation. Then I'm evaluating this at pi. So I put in pi. And I hit enter. And you should get 5.
Wait, x equals what? 5.
5.
So did you get 10? Oh, no.
Should get 5.
Oh, you're
Check
fine,
your
you're
equation.
fine. It says x equals 5, right? It's fine, your equation in y.
Check your equation and y equals.
I didn't put one in. Oh. What do I put in there? Dude.
Well, put in the velocity equation and y equals.
So just VT? No, 5 sine of
5 sine of t cosine of t.
Talking about.
Boy, the people watching the video are gonna be like, what is going on? Okay, look up here. Does everybody, relatively speaking, know how to use their calculator? And yes, you must put the actual equation into y equals before you use the shortcut. Okay. Let me go back to the notes here for a second. Okay, so we got 5. The units for the acceleration, meters per second squared. And I'm gonna write myself a little helpful note here so that I can remember. Find the derivative. It is math 8. It is with respect to x, d over dx. Inside the parentheses here, I'm going to put whatever my equation is. I stored it in y1. I'm evaluating that at pi. And my shortcut key was alpha F4. Assuming, of course, that I put my equation in y1.
I really have to write how I did it on my calculator.
No, you don't.
Oh.
Boy, we are quick today, aren't we, man? We brought our A game to calculus class. All right. Yes, we will. Here we go. So what does the integral from 0 to 3 pi over 2 of 5 sine of t cosine of dt calculate? We have already talked about it. This, it is math 9, but this is the displacement. Versus the integral of the absolute value is the distance traveled. Okay, so the units to the solution of this would be in meters. And there are two ways to find the answer to the displacement. Okay, if it is non-calculator, then we would have to add up the net area. If it is calculator, then we do a little math 9. Okay, so integral from 0 to 3 pi over 2. Okay, again, on the AP exam or my test, whenever they give you an equation, you do not need to rewrite it. A, it's faster to do what I'm about to do. B, you will not make a mistake like leaving off a negative. If it's a complicated equation, I'm just going to do this. B of t dt. Okay. If they have already defined the velocity equation, I don't need to rewrite that equation. I'm just going to write b of t dt. Okay, that will give me the displacement, which we're going to calculate in just a second. Over here, if I take the absolute values of the area, that will give me the distance traveled. Okay, so my integral would be the integral from 0 to 3 pi over 2. Absolute value, again, not going to rewrite the equation, just v of t dt inside the absolute value bars. So now, let me stop the share here and go back to the calculator. And let's calculate this. Okay, so now my other good friend with the calculator, math 9. Math 9. I'm going to put in 0 for my lower bound, and my upper bound is 3 pi over 2. Again, here, not going to rewrite the equation. It's already in there. So look, alpha F4 Y1 with respect to X. And I hit enter, and you should get 2.5. This is the displacement, correct. It does, and I will explain why in just a second. Okay, so now let's do the distance traveled. So we need the absolute value bars. So I need math 9 again. It's has the same bounds from 0 to 3 pi over 2. Okay, so look here for a second. Look up here. The absolute value, in case it's been a while, I'm going to go to math to num and then ABS. And it will put in the absolute value bars. Again, I'm going to use my shortcut again. Alpha trace Y1 with respect to X. And the calculator does have to think about it for a second. Wait for it. And then it spits out an answer of 7.500000574. Okay. So let me go back to the notes here. And make a couple of comments. This is 2.5.
Yes, I got that.
We're using math 9. This was 7.5. The calculator what was it, 574? Anybody want to guess how the calculator is calculating the integral? Wait for it. They're using a Riemann sum. All right. How many rectangles do you think the calculator is programmed to calculate? Somebody in second period said 4. And I'm like, no, no, it can't be infinite. It's a calculator.
How many zeros are up there?
No. So the calculator, the reason that it takes it a couple of seconds to process is because the calculator is doing a Riemann sum with 10,000 rectangles, all right? Which is a little bit faster than you can do it, but it's still, there's a bit of a delay. All right. Here's what's important for you. All right. You must write the integral for full credit. If you do not write the integral, you will not receive full credit. Ironically enough, bald answers are bad. Bald, bad. Integrals. Integrals written out, good. Don't be lazy. It's not good.
So what are we gonna write, just the thing above it?
You need to write that. In other words, or this. You can't just write 7.5. Okay, if you don't have an integral, it's wrong.
So if you don't have to write like the whole answer, you can just write 7.5.
You can write what I circled there on the
But
screen.
we have to write the.
You've got to have an integral, otherwise,
Is it not gonna half a point if I do the integral?
Jacob. We are not underachievers, we are overachievers. Write the integral. Here we go. Last thing, yes.
What about integers? Do you not need that?
I don't think it asks for unit. I think it, since we put that up there, if it asks for units, then yes, put them on there, okay? The last thing here on the first page is the position of the particle. And so to find the position, we have the initial value plus displacement. And the initial value in this case is 4. How do I know it's 4? Because they gave it to us, okay, in the stem of the problem. So, you find it?
Yeah.
It's there, okay? So we have initial value plus displacement. So I'm gonna write that out, integral from 0 to 3 pi over 2 b of t dt. And what is my position? I can answer the question now. What was the displacement? 2.5 plus the initial value of 4. So my position would be 6.5 meters. All right. Page 2. Here we go. Example 2.
Coach.
Yes.
So what's the absolute value one? Like if that one's displacement, so what's? that
This
one?
is total distance traveled. Okay, let me go back. I skipped this on the graph, okay, but let me explain why we got those values, okay? It's a trig function, so it's periodic. So this is 2.5. This would be negative 2.5 because it's below the x-axis. And this would also be 2.5. So if I'm calculating the displacement from here to here, this positive area and this negative area are going to cancel out. And I end up with just this 2.5 for the displacement. For the total distance traveled, it's going to be the absolute value. So this negative would become positive, and I would add all those together, which gives me 7.5. Okay, so total distance is absolute value. Just the integral is the displacement. Those two things could be equal depending on the function, right? We'll look at one later, but that's the case. But let me do this, and then I think this little chart will help you out here. Okay, so it says a particle moves along the x-axis. Its initial position at t is equal to 0 is x of 0 is equal to 9. So that information I'm going to use only with the position question. All right. If v of t is equal to 4 minus t squared for t between 0 and 3, find A, the particle's displacement for the given time interval. So displacement, integral 0 to 3 v of t dt. So take your calculator and find that. You can put the equation in y equals, or you can put it in your integram. I don't care. It's pretty straightforward on this. Live on the edge and do y2. And somebody help me out. What do we get? Okay,
But is it math one or math eight? Wait, math nine.
math 9
Why do we use the eight again?
for the derivative.
Okay.
Should be 3. What are my units? Careful.
Meters.
No. Centimeters.
Oh.
All right. Given. The total distance traveled by the particle. That's going to be the integral from 0 to 3 of absolute value of v of t dt. So take your calculator, plug that one in.
Hold on, guys, we can do it.
Seven point 6.6, we're gonna round, right? So there's no mark of the beast in our calculus note, 7.667 centimeters. All right, and finally here, the position of the particle, careful, at t is equal to 2. So position, again, it's initial value plus displacement. Initial value being 9 in this case that they gave us. And then we integrate not from 0 to 3, but from 0 to 2 of v of t dt. And so take that and plug it into your calculator. And let's crank out our answer. Yeah, no, just 9. And you should get 14.333. We're going to round to 3 decimal places and put our units on that. So here's a little helpful chart for you. Displacement mathematically is the integral from A to B of v of t dt. Distance traveled, the integral from A to B of the absolute value of v of t dt. Position is going to be initial value plus displacement. So it's initial plus the integral from A to B of v of t dt. And now, my dear students, it's time to set those calculators aside for just a second and head on into the calculus jungle. Here we go. Lots of fun and games. All right. Example 3. The velocity in meters per second of a particle moving on the x-axis is given. The particle starts at x is equal to -4 when t equals 0. Part A, describe the motion of the particle. So the particle is moving along the x-axis, so it's either going forwards or backwards. When is it going forward? And how do you know?
I can do it. Let me do it.
Go ahead. I am confident you can do it.
0 to 3.
Why?
The x-axis.
What's above the x-axis?
The velocity.
Okay, so in other words, this is a velocity graph.
Oh,
It is positive because it is above the x-axis from 0 to 3, therefore it is moving forward on the interval from 0 to 3. And it is moving backwards.
Oh, me again?
Why not?
3 to
You're on a
4.
calculus roll.
3 to 4.
3 to 4.
What do you want to set this now?
Well, I'm speeding through these calculus notes as quickly as possible, Jacob. If there's any time left over, maybe I will show you your test results. So here we go. Find where the particle is at the end of the trip. So what are we looking for here? Find where it is. Position. So position is initial value plus displacement. The initial value is -4. They gave it to me. Right there. The displacement, I gotta write the integral to get credit. So it's the integral. The time is, the bounds are going to be 0 to 4. And then I want v of t dt, but this time there is no math 9 because we are in the calculus jungle. So how do we figure out the value of the integral?
Area.
Well, I was gonna say, we just throw up our hands in despair and run away from our mathematical conundrum.
That's how I like that.
But I mean, how do you find people sleep at night if you would give a vote of confidence to that? No, we find the area under the curve. So triangle, area 1. Square, another area 1. Smaller triangle, 1/2. Under the x-axis triangle, -1/2. So my displacement would, you can look back on the first page and see one way to calculate displacement is to add up the net areas. So that gives me 1 + 1, which is 2, and the 1/2s cancel. So my displacement is 2. Therefore, my position is -2 meters. It's negative because the initial value is -4 plus the displacement. So -4 + 2 is -2. Find the total distance traveled by the particle. Again, write the value of the, write down the integral. And we do absolute value of v of t. And again, no math 9. But I'm gonna add up the absolute value. So the negative would be positive, and I get 3. And D says true or false. If the initial position was instead x of 0 is equal to -3, the position at t is equal to 4 would be positive. I say,
I don't know.
you say,
I'd say false would be negative.
it is false because the displacement is The displacement is 2. So if I start at -3 and the displacement is 2, I'm still at -1. Whew, I'm glad we survived relatively unscathed that jaunt through the calculus jungle. Now get those calculators back out. Whew, I just feel so much better when I can hold on to the calculator there. Here we go, last example. An object moving with initial position of 8 meters has a velocity of v of t is equal to 1.6 t squared plus 5 meters per second. How far did the object travel after 4 seconds? So this is a total distance question. I need the integral from 0 to 4 of the absolute value of v of t dt. So you take it from there, take your little calculadora. And what do we get? 54.133 meters is what you should get. So now, do me a favor and calculate the displacement. This time without the absolute value. The integral from 0 to 4 of v of t dt, but not the absolute value. And what do we get?
So I definitely accidentally just did the not absolute.
Okay. So if we do the displacement, you will, or if you did the displacement originally, as it were, you will get the same answer. Why is that? Because the object does not turn around. Okay. And therefore the area under the curve is always positive. Mathematically, why is that the case? Well, what type of function is this?
Exponential.
It's not.
Quadratic.
It's a quadratic. What does the +5 do to the parabola? It shifts it up 5 units. Therefore, on the time interval from 0 to 4, it is all positive area, right? And it does not turn around. Therefore, the displacement and the total distance traveled in this case are the same. Okay, so why is the integral from 0 to 4 of v of t dt the same? Because the object never turned around. The area, I'm going to say the area under the parabola is positive on the integral. Okay, so the final thing that we're doing here, I've divided the notes into 2 days, so we will pick this back up tomorrow so that you can see your little test here in just a second. Explain the meaning of the integral from 0 to 9 of v of t dt. So I've come up with a little acronym for you. Right? What was our previous acronym? Have we forgotten it?
No.
Okay.
You guys got it.
This is the nut stands for noun, units, time.
Just
Noun,
remember what we're supposed to do on English.
children,
You gotta do that.
don't worry, you didn't miss anything, Jacob. It's just like when you forgot to put the equation into the calculator. That was just a minor detail. All right, noun units time. So this is the displacement. So here's how you properly explain the meaning. The displacement of, what is it? What's the noun?
The object.
The displacement of the object. In meters from, okay, initial value to final value. Okay. Sorry, I said that wrong. Initial time to final time. Okay, so it's the displacement of the object in meters from t equals 0 to t is equal to 9 seconds. Put the units on that. So initial time 0, final time 9. So the last one here, explain the meaning of 8 plus the integral from 0 to 9 of v of t dt. Hold on, before I do that one, I could have said something else besides displacement. In this case, what could I have said? I could have said the distance traveled in this case, because in this instance, they are equal. That is not always the case, but it is in this case. Here, if I have 8 plus the integral from 0 to 9 of v of t dt, I'm going to say this is the position of the object in meters from t is equal to 0 to t is equal to 9 seconds.